Okay, so now we're going to go in the opposite direction. I am going to tell you that two angles are congruent or maybe they're supplementary. And then based on what kind of relationship those two angles have, then we can prove that the lines are parallel. So instead of me telling you from the get-go that the lines are parallel, you're trying to prove that the lines are parallel. You're going in the opposite direction. So, if I had this scenario, and I told you in our given, we knew that angle 1 and angle 2 were congruent. If angle 1 and angle 2 were congruent. Well, we know angle 1 and angle 2 are corresponding angles. So if a pair of corresponding angles are congruent, that means that those lines have to be parallel. So because those corresponding angles are congruent, then in the next step, then we can say the lines are parallel. And we are going to use the converse, because we're going in the opposite direction. We're switching them. We're going in the opposite direction. The converse of the corresponding angles postulate. So because we're starting with the angles being congruent, and then we're using that to prove that those two lines have to be parallel, this is the converse of the corresponding angles postulate. Okay, in our next situation, I'm telling you in the given that angle 3 and angle 4 are congruent. Well, angle 3 and angle 4 are alternate interior angles. So if these alternate interior angles are congruent, that means that these two lines have to be parallel. So because I told you that those two angles were congruent, we're allowed to say in the next step that line Q and line R are parallel by the converse of the alternate interior angles theorem. So because these are alternate interior angles and because I tell you that from the get-go that they're congruent, then in the next step you can prove that the lines are parallel by the converse of the alternate interior angles theorem. Next situation, I'm telling you that angle 5 and angle 6 are congruent. Well, angle 5 and angle 6 are alternate exterior angles. So because they're alternate exterior angles and because they're congruent, that means that line A and line B must be parallel. So because in my first step, in my given, I'm telling you that those angles are congruent, then I can say that the lines are parallel by the converse of the alternate exterior angles theorem. First, I tell you that those angles are congruent. Then I can tell you, then you can say that the lines are parallel by the converse of the alternate exterior angles theorem. And then finally, if I tell you that angle 7 and angle 8 are supplementary, well, angle 7 and angle 8 are same side interior angles. So therefore, those two lines, G and H, have to be parallel. The only way that angle 7 and angle 8 can be supplementary is if lines G and H are parallel. So because I'm telling you from the get-go that those two same side interior angles are supplementary, then the next step I can say that line G and line H are parallel by the converse of the same side interior angles theorem. That's not gonna fit, whatever. So the moral of the story is, the big idea is if you're trying to prove that two lines are parallel, so instead of me telling you that the lines are parallel from the get-go, if you're trying to prove that the lines are parallel, you're going to use the converse of one of those theorems or postulates. So if I'm telling you that the lines are parallel and you're trying to prove that the angles are congruent or supplementary, you're just going to use the regular old alternate interior angles theorem, corresponding angles postulate, etc. But if you're going in the opposite direction, if I'm telling you that the angles are congruent, if I'm telling you that the angles are supplementary, and then you're trying to prove that the lines are parallel, if you're trying to prove that two lines are parallel, you're gonna use a converse. And one more time, if you're trying to prove that two lines are parallel, then you're using a converse.